let's move on to number 4, where we have to write the sets in the set builder form. This may also seem a little tricky, but it's not actually that tricky. We just have to make sure that we are very explicit when we specify what X is, to what set it belongs, set of integers, natural numbers, whole numbers, is it a prime number, what is it? So we need to be very specific about that. And we also need to identify a pattern in these sets as to why we are seeing these numbers in the set and nothing else. So we have to identify a pattern that's very specific only to these elements of the set. So the first set is 3, 6, 9, and 12. So what we notice is that they're all multiples of 3, basically 3 1s, 3 2s, 3 3s, and 3 4s, right? Yes, they're all multiples of 3. Now I can generalize all of this as 3 times n, where n is less than or equal to 4. Or I can write the same thing, n is greater than or equal to 1, less than or equal to 4. Or I can write the same information as n belongs to the set of natural numbers, because natural numbers begin with 1, and n is less than 5. So I can write this set to be a set of all x such that x is equal to 3n, or 3 times n, and n belongs to the set of natural numbers, and n is less than 5. So that's number 1. Now, number 2 is very similar to number 1, except that here you have 2 1s are 2, 2 2s are 4, 2 4s are 8, 2 8s are 16, and 2 16s are 32. So you can basically write it as powers of 2, right? 2 cubed, 2 to the power 4, and 2 to the power 5. So the common element, the common factor for all of these elements in the set is that they are all powers of 2. 2 raised to a certain value gives you these elements. So you can write this as a set of all x such that x is equal to 2 to the power n. The reason I write 2 to the power n immediately followed by n belongs to the set of natural numbers is because n in the set starts from 1 and ends at 5. It does not start at 0. It does not take any negative value, so it cannot be a whole number or an integer. It has to be a natural number. So it's very important to specify this. And let's put a condition and say n is less than 6. You can write the same thing. You can write n is less than 6 as 1 less than or equal to n less than or equal to 5. You can write it that way as well. Moving on to number 3. 5, 25, 125, and 625. This is exactly, it has the exact same idea of number 2, except that here these elements can be written in terms of powers of 5. 5 power 1, 2, 3, and 4. So this can be written as a set of all x such that x is equal to 5 to the power n. And again, because you don't have 5 to the power 0 or negative integers there, so it's important to specify natural numbers where n is less than 5. Okay, so now let's move on to number 4. I think I want to change the color. So number 4 is basically 2, 4, 6, and so on. It's very clear these are all even numbers. So you can write it as a set of all x such that x is an even number. Or you can write the same thing as a set of all x such that x is equal to 2 times n, where n belongs to the set of all natural numbers. And yeah, that's it. We don't have any conditions on n because this is not a finite set, it's an infinite set. Sets like this, sets like these are called infinite sets because the number of elements is not finite, it's infinite. So every element can be written as 2 times n, where n is a natural number. So n starts from 1 and it can be anything, right? It extends all the way until infinity. So you can write, you can represent this in either way, both are correct. The fifth one is 1, 4, 9, so on, and 100. So this is a finite set because the number of elements here in the set is finite. And the pattern here is very clear. So you have 1 square, 2 square, 3 square, and so on, and 10 square, right? The pattern is pretty clear here. So you can write this as a set of all x such that x is equal to n square, and n belongs to the set of natural numbers, and n is less than 11. So you can also write this condition as 1 less than or equal to n less than or equal to 10. There's nothing wrong with either way of doing it. They're both equivalent. They mean the same thing. And it's okay to write like this, especially because you're specifying n belongs to natural numbers. This condition mandates that n is equal to or greater than 1 and is less than or equal to 10. So this condition here combined with this makes this equivalent to explicitly saying what n is.